Konnichiwa friends, my name is Aisman Samasi and I welcome you to the day 1 of 100 days of deep learning practice. In this week, we are going to learn about the history of deep learning and the map of deep learning. Okay, so in this week, this is basically an introduction week and we will not be getting any deeper or any practicals, mathematics or mind games. Okay, this will be basically an introduction lecture for our whole 99 days of deep learning practice. Okay, in this lecture, I am going to introduce you to the history of deep learning and how actually the deep learning started and how we are seeing basically the deep learning revolution around us. Okay, so this first lesson is for everyone, for students, for working professional, etc. If you want to just start deep learning. Okay, so when the deep learning actually started, okay, so the deep learning actually started during 1805 to 1890s when the theoretical foundations were built in the field of mathematics. Okay, like linear algebra, probability theory, calculus or optimization. Okay, so like 19th century was all about building the mathematics. You could like see here Bayes and the Euler here, or I think I mispronounce his name. So like in short, the whole 19th century was devoted to making the base for our deep learning. Now you may be asking, why is mathematics really important in the deep learning part? Okay, so like I will understand you with two memes here. You could see that this one meme is taken from an ex-user who posted, "Yep, we know you are scared to explore the labs." The whole AI, okay, which we see is actually machine learning and deep learning, but it is actually supported by math and Python. Okay, that is holding it all together. So like we could say that math plus coding is actually the whole supporting system of our deep learning and machine learning. Okay, and here also there's another meme is like an astronaut is seeing basically the whole deep learning, and he's wondering that it was all about maths, and here the next astronomer saying it always has been. Okay, so like in short, what I am trying to say is that the whole deep learning and machine learning is basically pure mathematics, nothing else. So the whole 19th century was devoted to mathematics and building the foundation for AI. In 1940s only we get the birth of artificial neurons in an research paper named A Logical Calculus of Ideas Immanent in Nervous Activity. Basically the person which published this research paper was so profound of the neurons inside the brain, so he wondered that what if we use neurons inside the machine and help it learn. Okay, so in the 1940s it was all about neurons. Okay, here in this paper we get the first mathematical model of a neuron. Okay, we also get binary input and output, and it was inspired fully by biology. Okay, brain can be modeled as computational was the whole agenda of this research paper. Okay, so if you got any time you could also read this paper. And in 1949 the great law by the Hebbian learning rule was given that neurons that fire together wire together. Okay, this one is to be becoming one of the top important lines during our neural training. Okay, In 1950 we get here Alan Turing, okay, who proposed the Turing test. If you don't know about this test, basically here we have an observer C which basically get an prompt from an computer A and from an real human B, okay. If this human can't basically differentiate between what is computer generated text or what is human generated text, then the computer have passed the test, okay. And this is how the Turing basically shows an benchmark from where the computer actually learns and behaves like human, okay. But the main breakthrough was occurred in 1957 when Rosenblatt proposed the Perceptron algorithm, okay. So here you could see that we have here data points here, blue and red, and the perceptron is trying to generally differentiate between the two data types here, okay. Basically it's trying to classify. So here the Rosenblatt basically trying to say that it's very much possible to train a neural network like this to for an basic classification task, okay. So it was the first trainable neural network. It was a single layer and it was hardware implemented, okay. So basically this is the point where basically the high price for the AI and it was showed around the world that the AI we could build, okay. Basically it was possible. But in 1969, like 12 years after that paper, 12 years, no, I think 12 years after that paper, the Means and Paper submitted a report that the perceptrons cannot learn XOR problem, okay. So basically here you could see that in classification the whole data point was here and there, and the perceptron was successful by building a single line that differentiates between. But what if the blue points are here and the red points are there, okay. So like the perceptron cannot ever learn that, okay. So basically Minsky and paper show that basically it's impossible for an perceptron to learn an XOR problem. So basically it's an fundamental collapse, okay. And it was this point where the research of neural network was abandoned. But in 1986 the three young scientists from the MIT, okay, build the backpropagation, okay. Their names are Rumelhart, Hinton and Williams, okay. Here they publish a paper titled Learning Representations by Backpropagations, okay. So in this paper the three MIT scientists basically showed the multi-layer networks can become trainable using an technique called backpropagation, okay. So like it was one of the wonderful idea you could say in the deep learning, the backpropagation, okay. And it is at this point basically the rise of deep learning was shown as a very good effort. But here the revolution was there, but the deep learning become possible in theory only, okay. I mean up to this the whole deep learning was in theory only, not practice. It's because these CPUs were too slow for learning. Okay, so like if you understand deep learning, you understand that we do deep learning using GPUs, okay, graphical processing unit. At that point, like 1986, there were no GPUs there, and plus there were very small data set. Okay, there were no data. Like if you had known about the performance versus data relation for deep learning and machine learning, here you could see that for small data set, the machine learning always perform better than deep learning, okay, for small data set. But as we increase our data, the deep learning works better. But for now, since we have small amount of data, the revolution was not possible due to small data set, okay. And so the deep learning was only possible in theory only. So basically the whole year until 2012, the deep learning was fully silent, okay. But here in parallel there was a new revolution going on by graphics card, okay. In 1980s to early 1990s, okay, the computers were coming along, and so the game was becoming an hobby for many people, okay. At that time, the graphics was handled primarily by CPUs or simple BBA cards, okay. Their games were also very simple, like the Super Mario, okay. It doesn't require any good GPUs or doesn't require great multiplication. But in the 1993, a new company was born named NVIDIA, okay. It was founded by Jensen Huang, and his entire goal was to accelerate 3D gaming, okay. Basically, this person is one of my favorite person, and if you are a gamer like techno gamer, BBS, etc., you would also love this person, okay. This is the entire person which have made 3D gaming possible today. So yeah, here the Jensen Huang had tried his best to make the company a global company, and even during 1999 the company was about to go bankrupt. So from the 1999 we get the birth of the GPU, okay. Its first ever GPU come to be known as GeForce 256 was launched in 1999, which basically coined the term GPU to the whole world, okay. The hardware was about transformation and lightning speed, okay. It also provided parallel graphic pipeline which was known as Miracle at that time, okay. So basically the whole revolution of the entire gaming industry was started from 1999. In 2000 to 2005, the NVIDIA increased their GPU capacity, okay, from GeForce 3 to GeForce 7, okay. Basically, Jensen Huang whole focus was to make that graphics card that could handle 3D games, and as the 3D games required very high processing power, that power, if you could make it, that could change the entire world, okay. So basically Jensen Huang was seeing a new age of AI at that time, okay. And in 2007 only, okay, 2006, he basically, like a mad person, it was like a crazy idea, but he invested all his money where there wasn't any future except for what he saw, okay. He made in 2006 an CUDA device, okay. It was the biggest revolution ever at that time. The architecture was G80, which was basically GeForce 8800, okay. basically the whole meaning of the CUDA device is to help parallel processing for the matrix multiplication. So like instead of gaming here, Jensen invested all his money into parallel processing unit, which no one even asked for, okay, at that time. The CUDA was introduced. It was done in C and C++, okay. Developer now could use GPU for non-graphic tasks, okay. Like even the idea was crazy at that time. It took him like 6 years to really see the miracle of his idea, okay. At that time, like everyone was feeling like he had done an crazy thing, okay, in 2006 by building the NVIDIA CUDA. But we all are thankful to him for making the graphics card, okay. Like for example, our Grand Theory Auto, GTA 5, Just Cause 4, Hitman and various other games which we like today are entirely handled by GPUs. Like if there were no GPUs, we couldn't even imagine the gaming today, okay. In 2005, the year now, NVIDIA made their latest product named GeForce RTX 50 series, which was powered by Blackwell and AI, okay. So like it is one of the best graphics card today, okay, with all the latest CUDA core and optimized for AI and gaming. So we see here the parallel world here taking place, okay. So back to our AI revolution. Here also in 2010 a new competition was launched by ImageNet, okay. It was basically created by Fei Li and her team, okay. It's basically a huge competition where the top scientists around the world participate, and there were 14 million images, and we had to categorize into 20,000 object categories, okay. So there were images of cat, dogs, shark, even houses, humans, etc., okay, and we had to categorize it. It was one of the biggest challenge of that year, and for 2 years almost, nobody seemed to be winning, except in 2012 where one of the revolutionary year, the AlexNet was introduced by the three scientists, okay. And here you may even knew the first scientist here, okay, like here, okay, Jeffrey Hinton. He is also called the godfather of AI, and he is the one who introduced the backpropagation, and also now win the 2012 ImageNet classification with our deep learning convoluted neural network, okay. It also used in NVIDIA GTX 580 at that time, okay. So like it was introduced in 2006, and it took 6 years extra to show the world that what NVIDIA CUDA was capable of, okay. It was one of the historic day and one of the most important year for AI revolution. After this point, the deep learning became practical, okay. Before 2012 it was only about theory, but after the 2012, when we seen that it win one of the big contests, and the and because of the CUDA it was this fast, the AI changed forever and the deep learning became practical and GPUs become essential for AI. Okay, it was one of the most important AI revolution in history. From 2013 to 2016 we had a rapid acceleration in computer vision, speech recognition and natural language processing. Okay, and here the benchmark of the ImageNet, Minis data and CIFR where benchmarks were also crossed. Okay, but the main another breakthrough occurred in 2017 when the Google researchers published an research paper named "Attention is All You Need." It was all about a new deep learning model called an transformer. Okay, here basically instead of an AI model which understand first, like if we say the cat is sitting on the table, here an AI model first understand the cat, then cat, then on, then then table. Okay, but here in transformers the researcher, so that we don't need the sequential attention, we could use self attention here. Okay, so it is after this point when the attention became very much popular in the deep learning platform and the transformer become a new age. Okay, then here we also get the key models like the BERT, the GPT and the T5. The benchmark dominated were now Glue, Squad and Blue. Okay, also in 2015, just 1 year before the Google AI's paper, 15 co-founders made a new company named OpenAI. Okay, which also include the Elon Musk and Sam Altman. Okay, the current CEO of OpenAI. Okay, they came together and they promised to make a new company which will revolutionize the whole world. Okay, they started GPT training from 2018 and Google also started their birth training from 2018 also. Okay, and finally in 2022 the ChatGPT was launched on November 30. Okay, so after like 4 years of research and hard work, the OpenAI now published their new OpenAI model named ChatGPT to the entire world, and it is one of the big revolution where the entire world understand the power of the AI. Okay, in 2020 GPT-3 was launched, and from 2021 to 23 Clip, DALI and Stable Diffusion were trained, and in 2022 in the year last we get the whole ChatGPT which generate text and help us so much. Okay, so this was the entire history of the deep learning. Okay, so you could see here the bricks were put one after the other, and now in 2025 we are seeing an AI boom today. Okay, now coming to the entire map of deep learning. Okay, so how does the map of deep learning actually looks? So first we understand the basics of the neural network. Okay, first we will understand here the backpropagation, the gradient descent, the optimizer functions and etc. Okay, so here first we need to understand the basic neural network. Then we have our computer vision part. Okay, this part of deep learning specifically applies on the images and videos where we classify the image or classify and localize, or we detect an object here. Okay, like here cat is here, and here in image we have cat, dog and duck here. Okay, so this area of deep learning is about image classification, object detection and medical imaging. Then we have here natural language processing. Okay, this is all about speech, human language processing and time series data. Okay, so we have here RNNs, the LSTM and the GRU here. Okay, so this area is all about sequential modeling. Then we have here transformers. Okay, which was main published in the 2016. Attention is all you need. Okay, here this is all about large language models, the vision transformers and the multimodal AI. Okay, then we have here generative models. So the entire area of this is devoted to GANs, which makes photos, then the diffusions model, and then this synthetic data generation. Okay, so basically in other part area we are basically predicting. Here this part is all about generating new data or new images. Okay, and then we finally have here specialized architecture like autoencoders, GNNs and RAG system. Okay, these are basically specialized architecture for different tasks. Okay, so like we have the five entire map of the whole deep learning part. Okay, so with this I close this lecture. Thanks for joining me in this course. I congrats you for joining me in this course, as basically this deep learning is the one of the most hype job today, and it's also the modern fourth revolution of the science. Okay, so let's meet you in day 2 of the deep learning course, where we will learn about the tensors, which are basically ABCD of the deep learning. So see you in day 2. Thank you and bye bye.